Okay, in this video, we're going to talk about different types of shafts for transmission. So, we've looked at motors and linear actuators, and we talked about shafts in those videos. But in this video, we'll go into more details of the different types of shafts that are available. So, you can see here that typically the most important types that you'll see here are you have the straight. Under the N type, you have the straight, you have keyed. So keyed, usually what that is, let me just open it up actually. Yeah, so keyed, you can see here, it looks like this. I'm just gonna click one and zoom in on it. So you can see a key shaft will look like this right here, where there's a slot in the middle. And inside the slot is where you insert your key. So the slot is called a keyway. So the point of this key is so that it's good for higher torque applications. You don't have to worry about your screws slipping. So those are some advantages of using that. So some most of the times you see these straight ones. So you have straight. You also have the D profile. So these D profiles look like this. It's just literally a circle with a flat cutoff. That's a D profile shaft. So these flat surfaces are good for your set screws, which we'll go into details on another video. But you could see here that those are very good for that. And then you have different things too. So if we go back a few more, so we talked about the straight. You also have tapped. So tapped might be good if you want to secure something at the end. You can see this hole is threaded here, so that's what the tapped version is. And then you also have different ones where it's like hollow, a step down, maybe it's threaded. So threaded ones might be good if it needs to connect to something. So those are all different type of variations. Okay, so in this one, let's take a look at a more interesting case. I mean, we just talked about the keyed one, but let's go ahead and just take a look on how a keyed one would look like. So for this one, let's go ahead and choose a 1/4 inch diameter. And you have a lot of different materials too. So depending on if it needs to be like corrosion resistance, you might go with a stainless steel. You have different finishes, which will affect your tolerancing. So when you buy these shafts, you can see that there are certain tolerances when you look at the details. Some of the sheets will say, so you can see here, this is a undersized shaft, so +0 -1 thou. So when you decide on, what applications, most of the time they may be undershaft because it needs to fit inside something, so that'll make it undersized. And the length you could customize too. Sometimes if it's too long, you can cut it to length. But here you can see that this one here is 0.5 to 6. This is a keyway length. But under here, you can see sometimes this one, the ordering keyway length range is 6 inches, right? Okay, so let's just go ahead and download this and take a look. I'm going to go ahead and save this. Download is not working for some reason. Let me try one more time. Okay, so you can see this is your key shaft. And if you were to measure the shaft length, it's 3 inches long. I don't know if it's set it here in the McMaster. Yeah, 3 inch right here, 3 inch. Okay, so that says it. And if I clear this, if you were to redo this search, you could see that, yeah, there's a length here, the diameter. You could choose some diameter. say like 0.125, or and you could choose a length that you want. So you have like a 1 inch shaft, for example. But yeah, typically you should be able to choose a length. But here you can see it's a 3 inch one. But we want to see the right keyhole for this, or keyway. So when we looked at the drawings for this, we know that it's 0.093 and 0.046. So let's duplicate this tab and then look up keys. So the width was 0.093. So let's say like 0.093 inches in fraction. That was useful. So let's see if it has a better keyway width. 0.093. Let's see if it says it here. Okay, so if we're looking at a 332, it's going to be 0.09375. And we saw that this is 0.093. So the keys are going to be slightly oversized, and you typically will press it in. So we'll download this and check it out. Okay, so as you can see, here is a long stock. And we'll just cut this to 0.5 inches. So let's make a plane here. We don't need the whole thing. Let's just do 0.4 in the other direction. And we'll sketch something else on this plane. I'm gonna draw a circle, extrude cut this. Okay, so this is our key. And let's check the size. So this is 0.94 here, and then this here is also 0.94, so it's a square stock. So if I put this in assembly, okay, so this should fit like this. I could go ahead and mate this face onto one of this face, and then perhaps I'm just gonna mate it like this, and then like that. Okay, so this is how you put a key into your shaft. And then in the other videos, we'll show you how you actually integrate this. But at least you could see how you could put a shaft inside. Could put a shaft inside your assembly here. This is a keyed one, which is probably the harder ones. The other keys you see here, straight, flat, tapered, those are pretty straightforward. So yeah, hopefully you'll have a better idea on how to assemble keyed shafts here. And the same concept will apply when you're trying to assemble motors as well, since some motors that you purchase will have a keyed shaft. Okay, so if you found this video helpful, give a like and subscribe, and I'll see you in the next one.